That's good. I like it. Everyone's bright and breezy this morning, so that's good. More than I am. The chap in the room next to me was snoring all night, very loudly through the wall. So I didn't get a lot of sleep. So it was quite weird. Before we start, I need to share the disclaimer. Obviously, what we're going to say here is not the views of RSA, and also, there is potentially going to be some recording and things like that. So just have a quick read of that, just to make sure everyone's comfortable with it. So my name is Trevor Deering. I am the Director of Critical Infrastructure Solutions for a company called Illumio. And basically what that means is that I work with our engineering teams, with our product management, with our alliances teams, with sales, with system engineering, on how we build and work with customers to develop solutions within the critical infrastructure sort of area of the market. And for us, that's principally things like healthcare, energy, and what we're going to talk about today, which is manufacturing. So as you can probably tell from my hair and the color of my hair, I've been around a while. So I think I've done like 42 years in this industry. And I first worked on industrial control systems in 1984-85, where we were developing the ability to take really old telephone exchanges and upgrade them with all the new technology. And we used what was actually at the time a very recent development of something called Ethernet. But it was so new that no one had actually written any protocols for us. We had to develop our own protocols. And that worked fine. And then we tried to scale it up to the whole factory that we worked in. And we very soon realized the limits that Ethernet at the time had. And it was about at that time that General Motors, working with several other groups, came up with IEEE 802.4, which is Token Passing Bus, and they created something called the Manufacturing Automation Protocol, or MAP, which became MAP-TOP. So anyone who's been in manufacturing a while may sort of remember that. But what we're going to talk about today is something a lot more advanced, because we start to see things like Industry 4.0, industrial IoT, smart factories, all of these sort of things coming along. But equally, we have to deal with a lot of legacy. So there's a lot of equipment out there that's very old. So the good news is that you won't have to listen too much to me in this session. I have a guest, and he comes all the way from the fabulous city of Vienna. If you've never been to Vienna in Austria, recommend you go, especially near Christmas. It's wonderful. So I'd like to introduce my good friend now, Thomas Vavra from Mondi. So thank you, Thomas. How are you?
Hello.
So just tell us a little bit about yourself.
Yeah, Thomas Vavra, Mondi. I'm manager network and security operations for Mondi, headquartered in Vienna, which is a bit odd. We're publicly listed in South Africa, and so in Johannesburg and in London. I'm in IT for 27 years now. Originally studied African languages and business economics. Couldn't find any money into it. Financed my studies with IT, so here I am. Always worked in the manufacturing sector, except for a brief stint in the telco sector where I worked for Orange Business Services. And I'm with Mondi now for close to 20 years, in and out. Starting there as an external consultant first for Orange Business Services, and then being full-time employed for 10 years already with Mondi. For Mondi, this is a relatively short employment term. I mean, Mondi is a very slow-moving company with regards to personnel takeover, turnover at least. The oldest or the longest serving employee in our IT department currently holds 35 years with Mondi. So people tend to start with our company and retire with our company. I myself,
So tell us a bit about what Mondi does.
Yeah, Mondi is a paper and packaging manufacturer, so we do everything. We are fully vertically integrated, so we run our own forest, we chop down our own trees, we replant them, of course. Yeah, paper machine is something rather large, so I think 5 or 6 of those rooms would fit one paper machine. Yeah, paper machine costs you a few $100 million, so a few $100 million, which is nearly equal now. So you can't move it easily. So we have to take very good care of our forests. Forests grow tendentially in most areas of the world where we are active rather slowly, with the notable exception of South Africa. So a tree has a turnover time between planting and harvesting in Europe and in North America, 60, 70, 150 years. Yeah? Our oldest paper machine is 100 years old now, still running, still overhauled, still running good. Our oldest paper plant is from the 1780s and still running good. Yeah, and what do we do with those trees? Yeah, we chop them down, we plant them, as I said, turn them into something called pulp. So first we chip them. There's a big machine in our factories which turns a whole tree log of 5 meters length and 40 centimeters in diameter, so 1.5 feet, and yeah, that's 8 feet length, 10 feet length, yeah, into wood chips in 4 seconds. Yeah, so just chuck it in. Be very careful there, because if you fall in, the machine doesn't care. Then we turn this into pulp, and the pulp is turned into all sorts of paper. We do paper grades from fine printing paper, so no matter what you buy in Europe, most of it comes out of one of our factories. We do kind of outsourced manufacturing for all sorts of companies that sell paper. We turn this also into all sorts of craft paper, as we call it, and corrugated. This is used for wrapping materials, stuff in Europe. The Amazon boxes, for instance, come from us. Yeah? The carrier bags you get in the supermarket, the paper carrier bags is one of our products. We try to be as environmentally friendly, so we also do plastic, so that's also packaging material, but we try to replace as much of the plastic with paper on one side, and on the other side try to do as much research, well, do a lot of research into sustainable packaging. So plastics made out of corn starch, for instance. We've got a product that's consisting of a thin slip of paper. You put the ham inside or your cheese inside, and you cover it up with plastic that's biodegradable, and you can compost it, which is rather nice. Yeah? Big part of our forest has been handed over to World Wildlife Fund for management, so we also cooperate with them very tightly, so to be as environmentally friendly as possible. Yeah?
So everyone here in high tech who's worried about their long-term 3-year plan, just be thankful you're not growing trees. Yep. So as part of that effort. So that's great. We know what you do. So where you operate? Where are your factories?
Yeah, we try to stay away from, how shall I say, dirty wood. So we don't have anything in Southeast Asia or Brazil where the probability of getting wood that's not sustainably harvested is very high. Yeah? So we do it in Europe. We cooperate with a lot of local farmers. We have our own forests in South Africa where we run the forests. We've recently acquired even a paper pulp plant at the moment in Canada, yeah, where also sustainable forestry is being done. Yeah? And all across North America, and we export to Africa, Southeast Asia, and have our own production facilities there, which bring their own set of challenges, because yeah, our production facilities are greatly varying in size. As you see, we've got paper mills. These are normally large, yeah? And all sorts of converting plants. In total, we've got 110 production sites, yeah? Plus about 70 sites where we do anything that's surrounding us, so from storage to sales to forestry operations, where we are all operating our own networks into the trees, literally into the trees. So we set up masts and do relay stations so that our forestries can be equipped with IT and everything is automated. Yeah?
So you're talking about their mills and converting plants. So let's actually look. So this is, I believe this is a mill.
This is a mill, yes.
This is
our mill in Štětí in Czech Republic. Yeah? You will see these are rather large, so a medium-sized city easily fits into one of our mills. If you use Google Maps and search for the addresses of one of our mills, you don't have to zoom in, you will see it immediately. Yeah? They're consisting mainly of several parts. So you've got, of course, a lumber yard where all the lumber is delivered. That's coming in from via train, or preferably, or sometimes via truck. Yeah? Here we've got a nice big train track bringing lumber. Yeah? Then this is converted into wood chips, as I said. Yeah? So big piles of wood chips are visibly easily also on Google Maps. Anything that can't be turned into paper, yeah, is being sorted out. One of those nice chimneys is a power plant. Yeah? So we convert basically anything that's not convertible into paper into our own energy. So we produce our own electricity. We produce the process heat that we use for production. making us by and large independent from carbon fuels. Yeah? Then this is turned into paper. And then, of course, paper production uses a lot of chemicals. These are some of the other chimneys. We recover those chemicals because they're expensive nowadays. Yeah? In the olden days, paper production used to be dirty. So clean river up to the paper factory, dirty river behind it. Nowadays, nobody can afford to waste any chemicals anymore. So we are producing as clean a water as we pump in, we pump out. Yeah? We also have a big wastewater treatment facility, usually also serving the local community. So if there's a local town nearby, yeah, they're just, how shall I say, one of our customers for the wastewater treatment, one of our customers for the electricity and the public heating. Yeah? So we usually operate in areas where it's remote. Yeah? There is not a lot of infrastructure, but a lot of forest around. Yeah? So we are normally the operators and the providers of the town for energy, power, fuel consumption, whatever. Yeah?
So from an IT perspective,
Yeah.
obviously with this very big plant, lots of sensors, lots of IT, OT equipment. How many sort of systems are in?
Guesstimate is between 10 and 15,000 connected systems. Yeah, that might be anything from a humble PLC to a big server. Yeah? Cluster operating the power plant, cluster operating the wastewater treatment facility, all sorts of production control systems, the ordinary IT systems, print servers, SAP print servers, whatnot. Yeah? So you've got a lot of things that are connected, especially people are becoming more and more creative in connecting things. Normally all those things are converging at certain points. Yeah? And these are the control points that we try to ensure. Yeah? That's a converting plant, very nice and neat, very small. Yeah? So typically those have between 30 and 700 people. There we are converting the paper that comes in into either corrugated or bags or anything else. Yeah? They are distributed around the globe. We ship the paper there, yeah? And then turn them into boxes or any other product that our customers might like. Yeah?
So I shared what kept me awake last night. So what actually keeps you awake?
What keeps me awake? Targeted attacks for financial activities reasons. Yeah? We are publicly listed companies, so everybody knows our accounts are visible on the stock exchange. So we don't do badly financially. Yeah? So having a nice juicy target, I mean, we're not as juicy as a bank and not as interesting as a bank, yeah? But still a sizable production organization of 22,000 people. If you wipe it out with a crypto Trojan, this would be highly inconvenient. Yeah? Then there are script kiddies, yeah? People being sloppy in their day-to-day work, people clicking on stuff that they shouldn't. Yeah? Somebody has malware as a service, tries to run a small business model, encrypt a few PCs and get a few bob out of us. Would not be nice, wouldn't be fun, yeah? But things happen. Yeah? The world is not perfect. Yeah? Suppliers and partners are a big concern for us. Yeah? So paper industry is comparatively high-tech compared to some of the operators and companies that we work with. So especially transportation companies are usually small, not very well equipped with IT. Yeah? But also some of the companies that produce heavy machinery. Yeah? They are very good at producing a paper machine. Excellent. Really, really top of their class. Yeah? But not so brilliant at building secure IT systems. So they bring something in, yeah? And sometimes their laptops have things on them that you don't find desirable in your environment. Sometimes, the maintenance connections can be a source of trouble. Yeah? Because if they are attacked by somebody, and we've got a lot of people who are connected to our company, and if they are attacked by somebody, it can have an immediate impact on us. Yeah? And it would be not very fortunate to bring one of those paper machines to stand still. Yeah? Paper machines are running 24/7. Yeah? So stopping a paper machine is a big effort. We have places where we've built a hotel, just for the maintenance portion of the paper machine. 400 people fly in, 3 weeks standstill, and then you restart the machine. If you do a forced shutdown of such a machine, you can estimate that if you kill it with something like a crypto Trojan or other malware that kills the system, you've got a few days of cleaning out the pulp that immediately congeals, and you've got a lot of work to do. So that's a serious concern for us. And then internal IT admin, that does something rogue or something, how shall I say? cheaper, because they're always under cost pressure. They try to find a better solution. Sometimes they found a solution that isn't really a solution, but some, how shall I say, advanced kind of spyware that acts as a solution. That's always a concern.
So I mean, that's the sort of the big thing. So we've had conversations about IT challenges, the everything is connected. So the one I'm interested in, the geographic personnel challenges when you're dealing with 100 sites.
Yeah, I mean, we are paying our people nicely. This is a good company to work for, and you're going to work for it for a long time if you wish so, unless you misbehave. But normally we are treating our IT people very nicely. But the areas we are operating in are not exactly Silicon Valley. I mean, some of the places we are in have 300-400 kilometers to the next meaningful town. Finding a person there who's a very good networker, a security specialist, a server specialist, system operation specialist, is really hard. So we have challenges in finding the right people due to the remoteness of many of our plants. We try to get the local community to, how shall I say, educate people, and we are funding education, and we're trying to train people, and it's a good place to grow, as I said. So you can start in Mondi on the shop floor and end up in senior IT management. We've had such careers, and not a few, quite a lot. But finding people in some of the places, if somebody retires, gets ill, dies, you've got a very hard time replacing them because, the places are sometimes very remote.
So is it accurate to say that being able to have remote control and being connected and automated control in some of those areas is really important? Because one of the things I think you mentioned also is that if you have a failure, it's probably the maintenance team that's doing the changes, not the IT team.
Yeah, so we're operating 24/7, so you don't have normally IT staff on site 24/7. So a lot of the things that we do has to be simplified to a level where the local on-shift electrician is able to take out a PLC, plug in the new PLC, run a script or follow a cookbook, as we call them, and get the things reconnected up and running again. So that's what I mean with remote support is very important for us. Remote assistance from vendors, from internal people, from central IT even. We try to outsource all tasks as much as possible, but some of it we have to do centrally. Is crucial to those operations.
And I guess, seeing as you said that it takes 150 years to grow a tree and a long while to build a plant, that actually acquisitions are is the way to grow.
So
that brings its challenges.
A lot of acquisitions. So every year we acquire a few plants, mills, paper, whatever you name it, we buy it. These are sometimes sold because they are not in the perfect shape. So you buy something that somebody else didn't want anymore and treated it for a long time as if he didn't want it anymore. And if you look in your child's bedroom and look at their least wanted toy, some of their factories look remarkably similar. So you've got places where somebody hung a rack, I don't lie, hung a rack on the wall didn't support it, the wall broke down. How do you fix that? You don't build a stronger wall, no. You take a piece of sheet metal, nail it to the wall and hang the rack on the sheet metal. We had factories where it was raining into the factory and there was plastic tarpaulins on the racks. Cleaning those factories up and bringing them to speed is one of our business models, I've got to say. So we buy something that somebody thought unfeasible. We've got a centralized way and a standardized way of running factories. And those factories are then put to shape, made proper again, and operated according to our normal operating procedures that usually bring good profit and let the factories prosper.
So I guess if they're not keeping the walls up, the cybersecurity aspect must be slightly concerning.
Yeah, I mean, some of the machinery that we have is so old that the manufacturers don't exist anymore. So especially the IT manufacturers don't exist anymore. So you buy something, a paper machine has an average lifespan of 40 to 70 years. That's the duration for which they are built. Normally they're overhauled every year, but if you buy a factory that has been disregarded or mistreated for a few decades or a few years, nobody does this regular maintenance tasks. So you get stuff that how shall I put it? Yeah, should be in a museum nowadays. Yeah, and it's probably dangerous for health and safety. Yeah, and then you've got to start and do everything again and rebuild the machinery basically from hardware on. Yeah, so from really solid steel and add sensors, add new motors, add new controllers for those motors, add PLC for all the valves, etc., etc. So this is normally a major overhaul business when we do an integration. Yeah.
So tell me about the threat landscape. What are the threats that you see?
The threats that we see are the usual threats that I guess everybody in manufacturing sees. We've got very few very targeted attacks, although we've seen a few remarkably good ones recently, like a fake president attack with a fake voice, which is beautiful. Yeah. But the normal stuff that we see is somebody clicks on something, somebody installs a spyware that's hidden in a PDF that he's getting. Somebody tries to install somehow a command and control system on your servers, on your clients. They try to do sideways spreading. They try to do AD hacking, the usual things. Mainly it's Windows focused, interestingly. And we try to stop that as good as we can, and until now, knock on wood, we were rather good at stopping things. Yeah?
I can imagine. So, I mean, you're talking about, we've sort of spoken about some of the OT systems are outdated, been around for a while. Standstill costs, we mentioned, the time of getting that together. But interestingly, you spoke a little while ago about the sort of number of outsourcers and suppliers that are actually on site. So obviously keeping those guys under control is a challenge, especially if you're not there.
We've got about 1,000 external companies working in all sorts of sites. If you say, okay, what is an external company? Anybody who's got access to your systems is an external company. So they need to do maintenance from anything from the vending machines for the gloves that we have in the shop floor to the big paper machines. They need to have access. So, and you need to secure this access in any way. And if they bring something in, you want to limit the impact of anything that happens there. Limiting the impact can be done in multiple ways. But normally you can't do too much on their equipment because they come with their own PCs due to licensing reasons, due to whatever, because they've got their specialist software for maintaining the machinery. So they have to be in your network and you have to deal with those threats. And even if threats come in, you have to stop them and you have to be able to identify them. And especially in the stopping part, Illumio has been one of the most instrumental tools that we used in recent years.
So let's sort of pivot now and talk about the network itself. So let's talk about the segmentation and architecture that you've put in to do this.
Where did we start out when we started? So we started out with a standard DMVPN. DMVPN is a relatively flat network construction. I don't know who's aware of DMVPN. It's essentially going any to any. We defined multiple sizes from the very small warehouse on the right side to the very big factory on the left side. And then we found out, all right, this is rather nice, but it's also rather nice for anybody who's an adversary or who inadvertently wants to spread something in our network or intentionally wants to spread something in our network, because having basically an SD-WAN optimizes not only internal traffic that's desirable, but it also optimizes all sorts of traffic that's rather nasty. So if you look at this, this is a 30-gon. So a shape with 30 corners, and these are all the diagonals in a 30-gon. If you say, okay, you don't have 30 sites, you've got 180 sites, and if these are not 180 sites, but behind all those sites are about 50,000 IP connected devices, the number of possible connections for any attacker gets near infinite or very hard to calculate. I tried to depict it. I found a program where you can do those things on the internet, but it used to be ending up in a gray area and you didn't even see a single line anymore. So the number of possible paths to an attack is enormous. So what we started out with WAN segmentation. We're still running this. This is done with Cisco TrustSec, where you have a segmentation pattern where you can say, okay, this IP list is accessing our network. This IP list has a certain, how shall I say, status. So this is maybe my OT systems. These are my office. These are my printers. And then you can say, okay, can an office worker talk to another office worker's PC? Can a printer talk to another printer? Doesn't make a whole lot of sense, no. Can an office worker talk to a server? Then you come one league higher and say, okay, can an office worker from this location talk to an office worker of this location? Doesn't make a lot of sense, block it. Yeah? But the problem that we found with this was excellent system in principle, yeah? But if you want to scale it, yeah, and say, okay, you've got 10, 15 categories of PCs or workstations or devices in any of the sites, yeah? In the larger sites, we calculated closer to 40 classes of devices, and you've got a matrix, yeah, where you say, okay, 180 locations, 40 classes per site. You do a site classification, you end up with a matrix that's so huge that not even a browser can load it. And this is administered in Cisco ICE, yeah? And we tested it, we really tested it, we wanted it to do it, 15,000 times 15,000, the matrix, yeah? It just crashes, yeah? So the operating system isn't able to cope with it, and the browser is unable to load the matrix afterwards, yeah? So, bummer, because basically what this leaves you with is a relatively open system. Better than nothing, significantly better than nothing. So to give you an idea, we did calculations and we did measurements, how much traffic a plain wide area network segmentation disregards or kicks off and turns into deaf null. Yeah? It's close to 80%. Yeah? In some cases it was close to 90% because all the Microsoft protocols that are rather chatty, all the other operating systems that are rather chatty, produce a lot of rubbish that nobody wants to transport, yeah? And if you throw it away, yeah, 80% of your network traffic is instantly gone. Yeah? So this does bring a lot of benefits. So can't say anything bad about Cisco TrustSec. We still use it. We still keep it as a strategic product. But yeah, for spreading or stopping malware, it didn't really cut the mustard. Yeah? So as I said, you've got in the classical segmentation, if you distribute it around the globe, no chance. Yeah? There's very little knowledge about network requirements. Yeah? If you do the segmentation metrics today, yeah, and your business decides to restructure and suddenly they decide to produce this there, and the teams are moving, the shop floor workers are moving, you have to redo your whole segmentation metrics. So good segmentation today, yeah, can be very annoying and very hard to cope with tomorrow, or you will have to create 5,000 exceptions that make the whole segmentation concept void. Yeah? So keep the wide area network segmentation, keep it, yeah? But keep it to a minimum. Yeah? In the segment, the lateral movement is not stopped. Yeah? So that's a big con, yeah? Unless you are able to push the segmentation down to your really last switch in your factory or in your bank or whatever you're operating. Yeah? The in-segment movement is not stopped by this. Yeah? Also, you can't stop command and control traffic usually with it. Yeah? So the lateral movement in segment is always a big concern for us because somebody clicks on something, has something, and it moves sideways immediately. Yeah? Yeah, and the big problem was that data centers, in our case, are by and large either cloud-based or outsourced. Yeah? So outsourcers don't let you implement microsegmentation or Cisco TrustSec or LAN-based segmentations in their networks normally. Yeah? So they've got their own networks, they've got whatever they use as a LAN switch. Yeah? This does not stick to your standards, it sticks to their standards because they're data center operators, it's their business. Yeah? So if you come along and tell them, hey, we've got 10 servers in your data center, we would like to introduce TrustSec to your network, he says, nice, I've seen this, cool, but no. Yeah? And also some of the data center operators are now operating their own Cisco TrustSec matrix for segmentation purposes between customers. Yeah? So they're keeping everything in a more or less flat network and segmenting the customers with secure group tagging. Yeah? If you come along with your own set of secure group tags, their metrics will be a mess. Yeah? Is you're limited to 65,000 secure group tags, mathematically at the moment, this doesn't work out. Yeah? Yeah, and if you start, hey, we do a firewall between all those segments, we don't use TrustSec, we use something smarter. Yeah? Have a look at what Microsoft presents you, what's required for Active Directory authentication traffic. Yeah? So that's as close to IP any inbound, outbound as possible. Yeah? So segmenting this based on firewalls is as rubbish as possible. Yeah? So you can put a firewall there, it will use a lot of money for operations, it will use a lot of electricity, but it will not do much with the exception of possibly finding some brute force attacks and similar things. Yeah? So what we started out with Illumio. So Illumio is an agent-based segmentation system. Yeah? And what you do is you deploy all your agents on all your machines. Why did we choose Illumio? Because we've got a lot of strange operating systems, as I told you already, stuff like SUSE on Power, AIX, and whatnot. Yeah? They're supporting nearly everything. We even deployed it down to stuff like embedded screens on PCs on production machinery. Yeah? And then you will see a matrix that looks very much like this. So this nice spaghetti was the starting point where you can say, okay, this is what you will see how all your flows look like in your network. Yeah? This automatically is generated by Illumio once you illuminate things. So basically you install their agent. Yeah? And what you want to end up is this. Yeah? So you've got a clear segmentation pattern, yeah? And you can define what goes where and what should not go where, yeah? And what can be moving within any segment that you define. Yeah? So the first step is illuminate. So you install the agent, put it somewhere. Yeah? Then you say, okay, what server landscape does this server belong to? And so you map out your applications roughly. Yeah? You will have to redo it possibly once or twice. There are a few clever people at Illumio who help you with not creating too many segments and not going too granular. Yeah? And thereby you can start creating your policy. Yeah? So
basically, and interestingly, I can't mention Illumio because that would be marketing. The way that what we're looking at here are different types of segmentation. So Thomas mentions sort of the challenges of VLANs and things like this. And as we move more and more to integrated systems, Industry 4.0, all of those sort of things, a lot more of those systems look and basically are running Windows and Linux. And so you have several options as to how you can segment those pieces. So at one end, fundamentally, you could sort of try and install like super agents like CrowdStrike and some of those sort of things, or you could do it basically remotely, which again has some challenges around if you lose connectivity, or you can actually use the host firewall. So within Windows and Linux, we all know there's a host firewall, and so being able to just control that gives us the capability to provide local granular access at that point. So when Thomas was talking about the challenges of lateral movement within a segment, by being able to control exactly what happens, we can actually knock that out. And the key to all of this really is zero trust. So zero trust is about really changing the way that we think away from trying to detect all the bad things and stopping it towards identifying the good things and allowing it. And that all comes down to identity. And so a lot of the time identities we start to add labels to things. So they could be labels based on department, or it could be what the device is. It could be the environment. Is it IT? Is it OT? Is it production? Is it test? It could be location, Brazil. It could be status. Is it clean? Is it infected? So I noticed on one of Thomas's diagrams there was a circle with nothing in it. And I think that's the quarantine circle. Mm-hmm. So if we change that to quarantine, then it changes those rules. And so the rules are applied basically to the labels. So if we think about this, if we start to apply labels to all our various things, our OT devices, our IT devices, and we can start to then think about what we do with that. So obviously we saw the diagram with all the connectivity and it shows us exactly what's communicating with what. But equally, if we then start to think about each of those labels as segments, we can start to change that and start to segment based on that identity. So it could be here that we're talking about the different departments, and we can sort of apply rules that said within assembly, anything can talk to anything using Modbus, but nothing can talk to anything using SSH. Or we could look at this based on environment, so an IT environment, an OT environment, and we could easily create a rule that says block RDP between IT and OT to stop ransomware moving between those environments. So that, the key thing, regardless of whether it's Illumio or someone else, the key things for all of this is about segmenting based on identity and being able to control that very simply, and being able to apply that level of granularity into the environments that Thomas was talking about. So let's talk about deployment. So if you want to.
So deployment is relatively simple. I showed you, this is an actual screenshot from our deployment. We use Illumio's microsegmentation. Yeah? This is the data collector. Yeah? Highly distributed application. We use it in all the plants. What do people want to know in a production site? How fast are the machines running? What are they producing? And how good is the production quality? Yeah? Yeah, it's highly distributed. It's collecting all the OT data, so you're connecting it to all sorts of systems with a very fishy security status. Yeah? And if you attack one of those, you've got an ideal jump server infrastructure. Yeah? Think about your own company. What do you have as a jump server infrastructure? It might be your ATMs and the systems that control those ATMs in a bank. Yeah? It might be whatever, your point of sale systems in a shop. Yeah? If somebody gets hold of the central system that controls all those little systems that are standing out there, yeah, it's a dream jump server infrastructure come true. Yeah? And for us, this is the data collector, for instance. We've got a few of those because we've got not only production monitoring systems, which is the data collector, but also production control systems of all sorts. Yeah? But they are basically real killer applications in such a scenario. Yeah? So what do you do? Once you illuminate them, so basically you install the agent, they start talking back to the central server and telling them who talks to whom, yeah? What IP address, what service. It's basically a huge flow collector with an enriched information format where you see what service or what user is initiating what flow. Yeah? Sorry, I'm a little bit shy. I don't want you to see our internal IP addresses and host names. That's why they are blacked out. That's what those ugly black smudges are there. Yeah? But you can basically then see exactly what category of server is talking to what category of server. And that's what you start out with for building your rule base. Yeah? You stop building a rule base for a firewall, yeah? But you say, okay, hooray, I start out with building a rule base for my patching system, for my virus control system. And then I start with the application systems. Yeah? So you start with the we call them hygiene systems first, where all your time servers are in, your control, backup, whatever systems. Yeah? And then you start building everything else around it. Yeah? Good. How do you segment it? Yeah? You segment it normally along application lines. Yeah? So you first, as I said, start building the rule base for all those hygiene systems. Yeah? And then you've got two sets of rule bases that you can build. One for the traffic that's within the segment and stays in the segment. Yeah? So that means that a database server can talk to the application server, yeah? Or an application server can talk to a database server only over the Oracle ports or over the SQL Server ports and nothing else. It can't even ping it, yeah? Because it's not necessary. Yeah? The same you can do outbound, and there it's getting interesting, especially for security. Yeah? This already hinders the sideways spread of most standard viruses, malware, whatever, significantly, because then he would have to figure out, because you don't see anything on the operating system, he would have to figure out which servers is he actually able to reach from this box. Yeah? That's a lot of hard work and a lot of handiwork. Yeah? That hackers are normally too lazy to do. Yeah? And then he would have to move to the next server and then figure out, if I want to move on, how do I move on from there? Yeah? And then you've got a set of application traffic that goes to the application group. So who can access what, how on this application? So who can reach the servers that are application servers? Who can reach servers for whatever, middleware connections? Who can reach the server for data exchange? Yeah? Who can reach the server on actual web interfaces? Yeah? And you can do this based on categories. So all your sites fall into a category. We group them by site names in our case. Yeah? So others might group them into production sites, distribution sites, and sales sites. Yeah? Might also be a valid grouping for other companies. Yeah? For us, the locations were more or less the interesting thing. Yeah? And thereby we reduce the attack surface immediately per application level to exactly the ports that each individual site is needing. Yeah? You now say, oh, looks all nice, yeah, but I've got a few hundred applications. Yeah, we also have a few hundred applications. Yeah? The effort for creating a rule set for one application at the moment. So if you say, okay, hooray, we're getting a new application, we deploy the agents, ramp it up, have a look, let it run for a week, collect some data traffic, see what they are doing, yeah? Until we've got the final rule base, yeah, is about 3 hours, yeah? Usually spent in 3 team sessions a week apart. So first is you do an initial draft of what you think is right and what looks like application traffic and doesn't look like absolute rubbish. Yeah? Then you talk to the application owner. The application owner tells you, nice that you identified it. This is not the way it should have worked. Please eliminate those 5 ports and this service doesn't run at all. Yeah? So you can do rules on Windows based on services. So for instance, port 80 wouldn't be open for anything, yeah? But port 80 would only be open for Apache.exe or Internet Information Server. Yeah? Reducing again the attack surface because nobody can use this port then anymore for anything else. Yeah? Second stage is that you review the rule base together after a week, implement the changes, yeah? Then after a week another set of, how shall I say, traffic information data is available. Normally this is also already a rather refined rule base. Yeah? Giving it back to the application owner. The application owner says this I can identify. Yeah? These are the final changes to the rule base. In the 4th week you agree on an activation date where normally we activate first the dev instance, then the test instance, and then the production instance of any application. And thereby have in full enforcement normally within 2, 3, 4 weeks. From starting point, I don't know anything about the application, to hooray, we finished the application isolation as much as possible. Yeah? Those rule bases are never perfect. Yeah? I kid you not, they are never perfect and they will never be perfect. Yeah? Some of them you have to err on the side of functionality, yeah? Because erring on the side of caution will mean that it doesn't work anymore. Yeah? Erring on the side of functionality means that you're slightly more open, yeah, than you would like it to be. Yeah? Erring on the side of caution would mean that it doesn't work. Yeah? So you will always be slightly more open than on an ideal scenario, unless you know your application so perfectly. In some scenarios I can think that this is possible. In our scenarios where we have a lot of legacy applications, frequently people are unable to tell you what this protocol is exactly doing, yeah? And sometimes even the manufacturer doesn't really know. Yeah? But you will still be 1,000 times better than a classical firewall segmentation approach where you say, okay, hey, you've got my VLANs all concentrated on a firewall, the default gateway is the firewall, and anybody who wants to talk through the firewall goes through a rule base. This is miles above it. Yeah? So you basically create a lot of rule bases, yeah? And what do? The magic thing is that they auto-converge. Yeah? So you don't have to create a rule base where you have to write a rule base for your Active Directory and then every application needs to have the rules defined for Active Directory. Yeah? But it auto-converges all those rule bases together. Yeah? So you write the rule base for one application. Yeah? So that's why you start out with applications that everybody needs, like backup, like your patch management, your time server, your DNS and whatnot. Yeah? That's what you start out with. Yeah? And then you start building the application rule bases, because then they auto-converge and everybody gets the rules, or every server gets the rules that they actually need. And if you've got a new global application, like we've got, for instance, in our case, CrowdStrike in use, yeah? The CrowdStrike rule base is one rule base that you add globally for everybody, yeah? And everybody is able to add to reach CrowdStrike and use CrowdStrike. Yeah? So that's an incredible advantage. Yeah? And the deployment time, so if you define a new rule base and say, okay, hooray, I want this out now because I've got now CrowdStrike instead of everything else, yeah? Is a few seconds. You say, okay, CrowdStrike rule base defined, submit, and it goes. Yeah? And you receive rather immediate feedback because people immediately start complaining if anything doesn't work anymore.
So, Thomas,
yeah?
we're starting to run a little short time.
Okay.
We need some questions. We give people the opportunity to questions. I have a question. So obviously you have a lot of different manufacturers, vendors, different applications, and some of those are closed. There was obviously, you know, that's our box, that's our thing. How did you go about getting those guys to agree to deploy things like Illumio onto those platforms?
The advantage is that you don't change the operating system with this system. Yeah? So you deploy it, yeah? And what it does, it modifies the filter driver rule base of the operating system. So you don't modify the IP stack, the network stack of the whole operating system. You just put something into the rule base on the operating system, and that's something that most vendors will accept. Yeah? And also the impact on the processing CPU power is marginal. So if you deploy it, yeah, nothing normally happens. Nobody notices it's less than 1% on a typical workload. Yeah? The advantage is that you don't lose your warranty with any of the vendors that you've got in your network.
So we have a couple of microphones. Does anyone have a question? Have questions? Oh, there's one there.
Yeah.
Hey, my name is Lou. I'm working at Home Depot. And one of the topic you talk about today is about visibility. I'm also looking into using logs to help organizations, right, to achieve visibility. You mentioned about the data collector, right, deployed to observe the OT environment. I'm wondering what kind of methodology or technology you use on this data collector. Do you deploy it on the endpoint on your plants, or is there any traffic mirroring to the trap infrastructure to kind of capture the data, right? Because all the visibility stuff need to rely on what kind of data you collect.
Yeah. No, the data collector is an application in our company. Yeah, so the data collector is an application. Sorry for being unclear. Yeah, the data collecting for the network traffic is done by Illumio itself in a system called the PCE, the Policy Compute Engine, which is more or less the central brain of Illumio. Yeah, and all the Illumio agents send the data, the traffic information to the Policy Compute Engine, and there it's stored for several weeks depending on your sizing of your storage. Yeah? We have at the moment, I think, 6-week back storage, yeah? Where all the flows of all the workloads that we've got connected to Illumio are being stored. So this is all done in Illumio. The data collector is an application of Mondi. Yeah? It has nothing to do with Illumio. It's just one application that we secured with Illumio. Yeah?
Okay, thank you.
Sorry. So you've got, yeah.
We still use next-gen firewalls. So we use them for all sorts of advanced thing detection. So all sorts of advanced attacks like brute force attacks, similar things, DDoS attacks. We stop with standard firewalls because this is something that Illumio is unable to do. Yeah? But the attack surface is dramatically reduced. Yeah? So and also the rule base on the firewall is dramatically simpler because you can focus not on the IP-based rule base, you can focus only on the advanced rule bases. So what URLs you want. No segmentation done on firewall level in those data centers. Yeah. And we do a rough segmentation for certain DMZs, yeah, but that's more or less a, how shall I say, tradition. It's not required anymore. The segmentation that you get with Illumio is much, much better than what you get on the firewall. Yeah.
I think it's one that.
Are there situations where having the Illumio technology has lowered cyber insurance premiums, or how can it be talked to in that vein?
We've demonstrated in a pen test of our SAP systems the resiliency advantage of using Illumio. We had it behind the standard firewall, yeah? And then we asked a specialist company doing red teaming exercises, please get into our SAP systems and damage it as much as you can. Yeah? First we said, okay, do it with Illumio deactivated, standard SAP system, well-maintained installation, all the patches applied that are recent, 17 minutes, yeah, until they were on operating system level. Then we activated Illumio, and the company gave up after a week of trying. Yeah, they said, yes, they can still try something rather destructive, but after a week of trying, they were unable to get in. Those pen tests we regularly provide to our insurance companies. And, yeah, I know of a few companies who are in the lines of business, like finance, like insurance, who also use Illumio, and don't want to talk about it. Yeah? They are very happy having it. Yeah?
Thank you.
Question?
So I see we're getting the hook. Thank you, Thomas. That was really great. As I say, I just want to reiterate, Thomas doesn't work for Illumio. I do.
Yeah.
But, So if you actually want to know more, we are in north, that way. We're in the North Hall at the back, so come along, we can do demonstrations, we have some sessions. We also have if anyone's interested in Zero Trust, we have the godfather of Zero Trust, John Kindervag, doing some Zero Trust workshops on our stand. We have some sessions from various partners, including AWS and Netscope and people like this. So thank you for your attention. Hope you have a great day and hope you all sleep much better.
Yeah.
Thank you.